membranes give you very high quality water, and what drove us is an interest in recycling wastewater. We were truly ex-academic, ex-government environmentalists. And we thought if we can make a membrane that can treat wastewater, then we get drinking water, pollution problem over. So we kept looking for different kinds of membranes. And our research director one day came to see me and said, look, I have another idea. And this was the idea of seaweed, meaning that we can take membranes, put them into water, and put a slight amount of suction on the membrane and not require all that previous pressure, vessels, energy, and make it convenient for water operators to use. Prior to this product, every membrane in the world was made by water being forced through the inside of the fiber, and under pressure, the clean water would come out on the other side. We reversed the direction of flow first, but most important, we reversed the way the pressure is applied. Instead of applying pressure to make the water flow through the inside of these fibers with a great deal of energy loss, we made the membrane set into the water naked with no pressure vessel, a slight amount of suction on the inside, in many ways like a straw, and this gentle suction that one uses on a straw pulls the water through from the sides, not from the bottom. The bottom is closed, unlike a straw. The water comes through the wall of the straw. The town of Collingwood was under a health watch because cryptosporidium was thought to be in the water, and they had to find a solution. So Collingwood contacted us because they knew that we have done some work in this field, and because they were under tremendous pressure, it's a tourist town, and this happened in the spring, there were warnings about the water. We rushed and did our best to come up with a solution. This solution ultimately became a seaweed plant that is now still there. And the interesting thing was that this was the first significant municipal plant in North America with this kind of technology. We got an agreement whereby they would train people who are going to use this technology. And almost everyone who went to Collingwood bought a plant. So it was excellent for us. They were such good tour guides, and the plant worked so well that it really spread the fame of both Collingwood and the seaweed. One of the interesting questions is, why was Ontario the home for ZENON, which became the world-leading membrane company, and also the home for the world-leading ultraviolet company? There were many things in Ontario that, with hindsight, I can see helped us. Most important is our location. We're surrounded by 6 universities, not only McMaster, Waterloo, Toronto, Queens, the Western, etc. And there were bright young people that we could hire, and it was easy for us to hire the best. It was easy because we had a good story. It was easy because they didn't have to leave home, didn't have to go that far. Second, we were able to attract some research funding as well, which I thought wasn't very much, but when I look at some other countries, it was pretty good, at times quite good versus the rest of the world.